So, hello everyone. As you've heard earlier, my name is Ionuț-Baltariu, and today I will present how cybercriminals are exploiting the employment market through malware traps that are hidden in fake job offers. First of all, I'd like to mention some details about me. So, I am a software engineer and technical lead at Bitdefender, based in Romania. And at Bitdefender, I'm involved in the development of digital identity protection products, while also working on internal automation projects. My latest interests are directed in the areas of social media threats, such as account takeovers and malicious advertising, or malvertising. And last but not least, I'm an author on the Bitdefender blogs, having contributed to articles in which we analyzed the streamjacking phenomenon and various malicious advertising campaigns. We will start by offering details about the job offer scams, while also giving an example of a malicious hiring offer. We will then take a high-level look on the embedded coding assessment, continuing with a deep dive into the infection chain, which involves multiple techniques and the programming languages. And in the end, we will find out who are the threat actors behind the phenomenon and what are the conclusions of our research, while also leaving plenty of time for the Q&A. So first of all, what are these job offer scams that I'm talking about? These are attempts to infect developers with malware, or software engineers, while portraying as recruiters or hiring managers on various platforms such as LinkedIn, Upwork, Fiverr, even forums that have discussions about certain types of jobs. And in this process, developers receive coding assessments that hide complex malware within simple code. And these are often gathered from open source or public projects. On this slide, we can observe 3 examples of LinkedIn posts in which the users mentioned that they have either been contacted or were actually infected by the malware that was hidden in the coding assessment. So just one simple search on LinkedIn or other forums can give you an idea of how common this phenomenon has become lately. And as a tangible example of a compromise attempt, I will present my interaction with such a recruiter. And in the screenshots on the right, we can see the so-called offer. So it is a very generous one, being a remote job and paid either in cryptocurrencies or at least $85 per hour. And the hiring process is presented afterwards. As a first step, I would have to send my resume, followed by a test and a technical interview, well, which would never happen, and ending with a meeting with the CEO. We can say, oh, sorry about that. So we can say that we don't know the company of the CEO that would be, since the message is really very generic, and the name of the product, as you can see, is DEX platform, or decentralized exchange platform, without mentioning any company whatsoever. And also, if you really pay attention to the message, the English doesn't seem to be that of a native speaker, which we would expect since the name of the recruiter was looking to be native. Okay. Another detail that might be of interest is that the platform or the offer was actually mentioning skills that weren't really on my resume, I could say. So it mentions React and front-end developer abilities, but if one would look over my LinkedIn profile, he or she would see that I have no or limited skills in that area. All right, so besides the CV review, the recruiter asked for my GitHub, which I omitted on purpose from my custom-made CV. Furthermore, the question about my projects or contributions makes sense, and we will soon see that the malware is hidden in or within forked public open source projects. And as a final step, I received a Bitbucket repository. It could be a Bitbucket repository, it can be a GitHub, it can be GitLab, it can be any Git whatsoever, it doesn't really matter. It's just a coding repository that represented the part of code on which I would work in the company. Another feedback document was also provided, which had to be completed with answers to specific questions. And a late development to this campaign has also appeared. So they also send Figma projects, if you heard about Figma, in order to make the project or the company look or seem more genuine. And we can already see from the structure of the Bitbucket link, I hope you can all see it, that it's not credible. So it has a vague name. It's u_dex, and it's created by a seemingly random user called VTE3mox. And under normal circumstances, neither the username or the project name should belong to any serious company whatsoever. All right, moving on. So the structure of the project sent by the recruiters respects a pattern. As you've seen earlier, the usernames and the repository names are always vague or random. And in this particular case, we can see that all of the files were committed or uploaded to the repository on the 3rd of February, which is also atypical. So in a normal project, you would have more people that work on different parts of the project, and they would have different timelines for committing or changing files. And what we've seen so far is that all projects were written in either JavaScript or TypeScript, and we're using a runtime such as Node, and other well-known tools such as NPM, or Node Package Manager. If we take a closer look on a malicious repository, we can observe that the attackers take over already existing projects. So I've mentioned earlier that they either fork open source project or they just inject the malicious code. We will see that later. And the commit highlighted in red, so the first one from the top, was made at a distance of over a year since the last commit. So in reality, on the 14th of January 2025, that commit made by an unknown author, as you can see, with an email address that is likely to be stolen or just disposable, that commit introduced malware in the code base. And there are changes, you can see on the right part, made on a multitude of files, so that the malicious code is not that easy to find. They kind of force you to take a look on lots of files in order to see where the malicious change has happened. And in this other example, we can see that the file in which the malicious JavaScript code is injected, so that would be the one highlighted in blue, it's next.config.js. So the code in green is the actually malicious code that was introduced by the threat actors in this campaign, but we will take a deeper dive in this later. Moving back to the actual email address that has done this commit, it actually belongs to the Washington University, and that is really making us think that the attackers, as I've said before, are using compromised accounts to make changes like this in different repositories. Another detail that is interesting is the fact that the day in which the change was made is different from the so-called author date. And this was certainly done to offer a slight credibility when someone briefly checks the commit history of the projects, as we've done here. And in some cases, the commit history might not even be available. So imagine that they just clone a project locally, they basically erase the Git history, and they put that back on GitHub, and you would only get the initial commit that contains all of the files. Going back, so I've mentioned before that you receive a coding repository, you receive an offer on LinkedIn, but you also receive a document that is attached to this coding assessment. And reading this, we can figure out that it is not wished to only do a code review, so to statically analyze the code, but to actually run the code in order to observe how certain animations or functionalities work. And personally, I have not run the code or analyzed the runtime of the project, but in order to see if the questions actually make sense. I would imagine that they do make sense in this case, but already having the context of this malicious campaign, I have continued only with the static investigation of the code, which we will do exactly right now. But before we do a deep dive into the malicious code, I'd like to ask you a question, and could anyone tell me if anything is out of place in this slide regarding the VS Code editor, obviously? Okay, plenty of time. So I'm just going to highlight it for you. You see the slider on the bottom. The thing with this is it's totally unexpected, since at the first view of the project, we do not expect anything to be on the horizontal, right? So I'm just going to demonstrate this to you. If we have some patience when using the horizontal slider, we can observe just a bit more. We can observe the obfuscated code that was hidden without any issue, basically. So that would be, I think, around 700 spaces or something before the malicious code is actually seen. This was like a static way to introduce the code. Of course, this is prone to being detected by security solutions. But what we've seen after this, just lots of ways to dynamically load pieces of malicious code. And there are two examples basically here. One is just split into images. In one of them, the code is loaded from a third-party API controlled by the attackers. So if you look at the bottom one, you see just, if you know like JavaScript and malicious patterns, you would of course think that this is a malicious attempt to load code, because first they get the malicious code from that public service. So api.endpoint.io is not a malicious domain, it's a public domain. They upload the malicious code there, and they just get it because it's a free resource, it doesn't cost them anything. And later you can see that they run eval, so that would basically dynamically run the code that they obtained from that resource. But another interesting way that they've hidden their code, so if you look at the top image, you could see on the catch branch here, there's an error handler. So you would basically run error handlers whenever something unexpected happens, or whenever an error that you expect happened and you want to treat it somehow. But the thing with this error handler, so first, if you do a web request, this error handler would trigger whenever you receive a, let's say, 400 type or 500 type HTTP response. The thing with this is that the malicious domain, or actually URL that they've used, would always answer with a 500 type error code. So it would always go on the error branch. And if you take a look at the code of the error handler, we can see that they dynamically create a function in JavaScript that, like before, just loads the malicious code, but it does it in a more fancy way, I would say, rather than just executing eval directly on the code. And other developments that the threat actors have used before is just to basically encode their resources using simple ASCII algorithms that would, again, lead to certain domains. Right. We concluded that this JavaScript loader is, well, either carefully hidden in the source code, as you've seen on the video with the slider, or it's just dynamically executed from third-party domains that are either controlled by the attackers. So one was controlled by them, it was their domain, and the other was a public resource. And after we deobfuscated this code, it was, well, absolutely clear that it's malicious. And inside it, we find browser-specific locations, as well as identifiers for browser extensions. So every browser extension that you install has an identifier. I'm not sure, but I think it's like 32 characters. And you would see these in the source code of the malware. And moreover, the loader, so this being the loader, it obviously downloads another file that it also executes. And the attackers construct the command that executes the malicious script, or another malicious script in this case, based on the operating system. So if you have Windows, they would treat it in a way, and if you had the other operating system, in this case, I think it's Mac, or whatever, Linux, they would actually use shell commands in order to run the next stage. In some newer versions of the loader, we cannot really state that the code is malicious at the first look. And the hackers have added supplementary obfuscation layers by using both base64 and other simple encoding algorithms. And of course, you could decode the base64, you could go beyond the decoding algorithms without any issues, but at the first view of the malware, you wouldn't directly say that this is malicious. All right, and in this case, in any case, the behavior is identical. After you deobfuscate the code and you take a look at it, the loader has a double role, so it steals some browser information, and it actually ends up executing a Python script that continues the infection chain. Regarding the malware variants that might be spreading through this campaign, it is safe to say that the threat actors are constantly changing their payloads. And in this presentation, we are going to talk about Beavertail and Invisible Ferret, with the bonus Tsunami malware on the end. However, more recently, the threat actors have started using what is called Otter Cookie, which is like a spin-off of these two malware families. So Otter Cookie would be at its fifth version and could be summarized like a mashup between Beavertail and Invisible Ferret. And of course, they have used other samples in the past that were named Golem Ghost, Pylon Ghost, Ratatouille, and even Otter Candy. This would be the latest one. Going back to our Beavertail and Invisible Ferret flow, we've passed the malicious JavaScript files that download and start another Python loader. And this Python loader has the sole purpose of downloading other malicious Python scripts and executing them. So this is like another chain in the whole infection chain, basically. One common thing that that is consistent with all downloaded Python files is that they are obfuscated in a similar manner. Some scripts have just an additional layer of self-decryption using XOR algorithms and eventually base 85 decoding. But all of the samples had a recursive base 64 decoding step. And depending on the decoded script, there can even be 50 intermediary layers until the true source code is reached. And the techniques of the attackers, of course, change as time passes. And we have observed changes on the self-decoding algorithm in order to, well, basically avoid early detection of the malware. However, there are some scripts that have been used repeatedly in this malicious process, and we will discuss them in what follows. The first example is named pay.py. I think it comes from payload.py, and it is the most complex one. It collects information about the system on which it runs. It acts as a keylogger and info stealer, and it also configures multiple backdoors depending on the operating system. So that would be either AnyDesk, which works on multiple operating systems. It could be reverse shell, and even other things in this case. And depending on the exfiltrated information, it is likely that the backdoors are used to continue the malicious process. And just imagine the case in which a device of a company, so yeah, you would receive this on LinkedIn, it would be an offer, you think, whoa, this is a cool opportunity, but you would run this code on your company laptop because it doesn't enforce any policies or anything like that. Just imagine how damaging malware like this could be, and we will even see how it goes beyond what we've seen until right now. As example functionalities, we can see on the script found on the left that it just gathers the internal and external IP of the victim. And on the right, we can see how it checks for keyboard events and copies the clipboard whenever certain key combinations are pressed. So this would be the keylogger behavior. Furthermore, the script downloads additional resources, and we can see just the /ADC route if you look in the middle of the code. It's from obviously from the attacker control domain. And after downloading and executing the resource, which is related to, well, AnyDesk software, it sends a message to the C2, so the command and control endpoint, through a socket, just mentioning the operating system on which it ran and the get AnyDesk words. Another specialized script that is repeatedly found in this kind of attacks is the one that targets web browsers. So everybody, everywhere, uses web browsers, and this is a typical target for these threat actors. This script exfiltrates information that is specific to the browser that the victim uses on any operating system. So I haven't really said it before, but I think everybody pictured the fact that the malware is cross-platform. It doesn't matter on which operating system you run it, it will figure a way to do damage in this case. And moreover, sometimes the browser stealer just acts like a loader for what the attackers call the tsunami injector. First, let's just see on this slide the classes that the attackers have come up for, well, basically every operating system. And the stealer specializes in Chromium-based browsers, such as Chrome, Opera, Brave, Yandex, and Microsoft Edge. And you can see in this code the relevant paths that are, well, for the browsers, but on every major operating system. The malware has the capability of decrypting values that are protected in the realms of the Chromium browsers, as I've mentioned before. So that would be, well, login data from the browsers, credit card information, and the two select queries, the database select queries on the bottom of the slide, are actually done on the SQLite databases that are used by Chromium browsers to generally store information. So the first one grabs credit card data, such as the name, expiration date, and the encrypted card number in this case, while the second one retrieves the login operations that the user has done on the browser. And the encrypted card numbers and passwords are just simply decrypted using the functions like the one you see on screen, but on the top part, so the decrypt Windows password function. Earlier, I've mentioned that the browser stealer might also contain an embedded malware called the tsunami injector. And on the snippet found on the right side, you can see that the payload is run under the name of runtime broker. That would be the name on the bottom part of the picture. That's a common name in the Windows realms. And the executable is, of course, downloaded from a domain controlled by the attackers. But the process to obtain it is actually rather interesting. So they would just use 1,000 XOR encrypted paste bin URLs that might or might not, it really depends, contain the URL at which the malicious executable is found. So the malware will go through all of them, so like 1,000 paste bin URLs that are XOR encrypted, until it just finds the right one and it downloads the malicious executable. The malware that the tsunami injector downloads, so this is the tsunami injector, but we also have the tsunami malware itself. This is already a long chain. We'll just come back on it later. But this downloaded malware is just a multi-stage .NET application that uses a Tor, so the onion router, command and control endpoint. So it downloads a Tor proxy, and it is started on port 9050. Allowing all HTTP requests to be passed through this node further on. And the malicious part is downloaded after the Tor proxy is set up. And it is without a doubt a capable and multi-purpose malware, as all malicious modules run within separate threads. As expected from the threat actors that we will soon name, a cryptominer module is found. So this one mines Monero and Ethereum. And it's also capable of doing dynamic throttling based on the hardware resources. So it would adapt to your own hardware, I would say. And that means like CPU, GPU, and RAM. And it will also adapt on the user activity. So for example, if a full screen application is detected, such as a game or an application, anything like that, the miner would auto-limit itself in order to not raise any suspicion. So you wouldn't find any differences in what the performance of the games that you've run lately when running the game. So furthermore, it just suspends execution whenever a monitoring application like Process Explorer, Procmon, Task Manager, anything like that is run. So you would open it, but you wouldn't see the malicious code because it suspends execution before. The keylogger module is just capable of silently capturing and storing keystrokes, and this enables the agent to exfiltrate secrets that are not only stored on the system, but also private conversations and much more. The last two modules are the configurable so-called secret file stealer and the backdoor. And the behavior of the secret file stealer can be controlled by a config file. So you see it into screenshots here. This one is obtained from the Tor command and control endpoint, so it could differ depending on the time at which you run the malware or whatever changes the threat actors made. And for example, we can see that in this configuration, the stealer is enabled. Yeah, that would be the first, the parameter from the JSON. It's enabled set to true. And we can also see that it scans for documents, pictures, and so on, while also ignoring certain directories using wildcard strings. So funnily enough, that's on the right part. It just ignores the Eurotruck simulator directory in this case. Oh, that's on the left part, my bad. I really have no clue why they've done that, but it might have something to do with the structure of the directory and the fact that it contains lots of redundant or uninteresting files, I would say. On the right part, we could also see wildcard comparisons. So these are things that they would look for. And of course, you have wallets, seeds, mnemonics, everything that is related to the crypto realms. And you would also have words that are not only in English, so you would find things that are in French or I think even Spanish in this case. Right, so it was a lot to cover. And to sum up, let's just go again through the whole infection chain. So first of all, victims are being contacted on LinkedIn by fake recruiters. Not only LinkedIn, though. It can be Fiverr, Upwork, and a lot of other platforms. And these imposters mentioned that in order to get hired, you have to complete the coding assessment corresponding to a project on Bitbucket, GitHub, GitLab, doesn't matter, any Git hosting environment. And if you run the project, the backend typically uses Node.js as a runtime. And we've seen that the malicious JavaScript file is either hidden somewhere in the source code, so remember the slider in which you've seen the code on the right, or it's loaded from a third-party website which can be controlled by the attacker, or just a public resource, as we've seen with the api.endpoint.io. The malicious JavaScript, so that would be the first stage, also acts as a stealer, but doesn't go too deep into this behavior. But it also starts a Python process in the background. So this would be the Python loader. The Python loader then downloads multiple other Python scripts. We've covered 2 of them today, but it could be 3, it could be even 1. Sometimes it really depends on the versions of the malware that the threat actors are distributing. And one of them could potentially contain the Tsunami loader and obviously the Tsunami malware that we've analyzed lately. So the malicious samples that were presented today were named Beavertail and Invisible Ferret. And Beavertail is the initial loader, hidden in clone projects that have been modified by the attackers or just loaded from third-party websites. And the Invisible Ferret is or refers to the Python scripts that have multiple malicious functionalities. And the techniques, malware families, as well as the C2 servers that we found in the example scripts were attributed to the Lazarus group, or APT38 in this case. And furthermore, we could absolutely say that the crypto mining and cryptojacking behavior is consistent with the North Korean modus operandi. So we could say that these objectives align with the DPR case broader objective of evading international sanctions and all kinds of stuff. Right. The campaign that I have detailed today is also known as Contagious Interview, but it also has other aliases, and one alternative could be Deceptive Development. And even though it is analyzed since December 2022, so it goes a while back, the phenomenon is constantly evolving, and the samples are becoming more and more advanced while the threat actors adapt to basically any new technology that is of their interest in this case. And they put a lot of effort into avoiding detections from security providers. In conclusion, we can say that the Lazarus group and, all affiliated subgroups evolve in a continuous manner in order to not be detected by security providers. And in the last year alone, they have actually started to host interviews. So imagine receiving an offer on LinkedIn, receiving a message, a coding repository, all that, but you would actually end up in an interview. They would send you calendar invites. It would be something real. You would enter a meeting. There would be a person there. It could be a real one or a deep-faked one. So I think we all know that we can even live deep-fake ourselves in these days. And the thing with this one is that they put pressure on you live to run the malicious code or just to test the repository to see how you are doing in this case. So they would make you run it directly on your computer and not any other protective solution, I would say, like containers, like Docker containers, virtual machines, cloud, or anything like that. And moreover, they have been experiencing with developing malicious NPM packages. So everything you've seen until right now in this presentation was code that is either included in the repository, loaded from other third parties. So that's all in the code. But in newer versions of this campaign, they have started to use NPM libraries. So everything on the project would be clean. There would be no malicious behavior. But once you run the project, it would install the dependencies, and one of those dependencies would be infected in this case. Another development that's really, I think it's from the last month, from October, they have started to create code editor extensions. So imagine, I think lots of us used VS Code Cursor or anything like that that's based on VS Codium. In these code editing solutions, you can install plugins or extensions, you might say. And they have started to develop malicious code editor extensions that they would picture as necessary for running the project or just as a dependency for you to move on onto the next step. And another interesting development that surfaced lately is the use of generative AI. So yeah, well, I think everybody from, or most of us from this hall are already using generative AI solutions, chatbots and all that. But the threat actors are also doing that. So they just use it either as a coding body to improve their malware in this case, or just to straight up generate malicious code to learn about Windows internals, to learn about things that they have to code in their info stealers and so on. Right, so we can absolutely say that spreading the information about these job offer scams might save potential victims from future hacks. So I at least hope that everybody from this room will not get infected by an attempt like this, because it can be really easy to identify it after you've seen this, or even before that if you are really precautious. But another thing that would really save us in the future is just being really skeptical and double-checking, always double-checking code that you are supposed to run anywhere to just prevent a malware infection disaster. And as a bonus for those that well, reached the presentation and the ending of this presentation, I'm just going to leave two useful links for you. I promise this isn't malware. It's not anything like that. The first one on the left is a link to our blog post about the malware. And the one on the right, if you've used VirusTotal until now, it's a collection that contains most of the samples that we've discussed today. So, and on the bottom, you also have my LinkedIn if you want to connect. And yeah, that would be all. I think we also have time for some questions.
Yes, thank you so much, Ionuț. There you go. So we have a question right here, and then the gentleman right next to him.
Hi, thanks for the presentation. I want to ask you
a little bit closer.
I want to ask you if Bitdefender can help us with this kind of attacks now or in the future, or give us a heads up about some sketchy code.
Well, first, if you would read any articles that we put regularly, you would learn about these techniques. And of course, if you use well, any security solution, it would be likely to detect scenarios like this. Yeah, but even without this, I think that what I've said earlier, like the skepticism and the double-checking could basically just prevent this, and we wouldn't even need any security solution.
All right, then we have the next question, and then we'll come in front to you.
A bit of extrapolating the previous question.
Just a bit louder,
Yeah.
please.
How about now? Good?
Good. Yeah.
Okay. What do they do about the endpoint solutions? Because you are downloading file, installing, doing something like that. Do they do something about endpoint solution to stop them, detect them, these kind of things? I'm wondering, I mean, typically some endpoint solution at least would catch some of that activity.
So let me just understand if, to see if I've understood the question. What we could do about the fact that the user downloads malicious files? And
No,
there's
it's highly likely that on your machine, you're a developer and so on, you have some sort of endpoint solution, right? Security
Right,
endpoint solution.
right.
Wouldn't that catch any of those? Because they seem to go all in, kind of fetch everything, install, create processes and so on. Wouldn't that be flagged by such? I don't know if you tested that.
Well, it could be a complicated answer. It really depends on what security solution or how advanced the malware is. So it's always a fight between the two sides, the part that protects you, the endpoint security solutions, and the part that are trying to attack you. I think if you take a look on the collection on VirusTotal now, pretty much plenty of security solutions already flag this malware. But it could be that anytime they change the code and nobody would pick it. So it's just a continuous fight that we have to take.
Great, thank you. Then we have the next question right here in front.
So how often do Beavertail and Invisible Ferret pop up in other North Korean operations, like the DPRK fake IT worker scheme? Do you see that?
Well, in this particular case, I think Beavertail and Invisible Ferret is pretty much tied to this contagious interview campaign. But one thing I could say is that they are reusing code pieces and, well, of course, techniques, because these apply universally. But coming back to Beavertail and Invisible Ferret, I think at least 99% of the incidents were tied to this contagious interview campaign. You.
All right, thank you. And we have another question all the way up in the back. Mike is coming to you.
Yes, hello. Great presentation, by the way, on such an emergent threat. I was wondering if during your researches you have found out where do they exfiltrate this data? They are using Telegram bots. Where the data go?
Do you mean the exfiltrated data that they...
Yes, the exfiltrated data.
So yeah, they would just really exfiltrate it to their command and control endpoint. That could be either through Tor, as I've mentioned, the C2 on the tsunami injector, if the tsunami injector is present. Okay. Oh, right. They could exfiltrate it to any other attacker control domain that they are using in this case. But particularly to what we've seen until right now, it was mostly exfiltrated through the Tor command and control endpoint. Also the normal files, but the, well, secret file stealer files.
Awesome, thank you. Raise a hand if there's any other questions that you would like to ask. Yep, we have a question in front. Okay, it's going to be a long walk. If you can keep your hand up. Yep.
So you mentioned that Bitdefender is tracking this cluster, this campaign as APT38, which would be Stardust Cholima or Colima, whatever you want to name it. Is there any particular reason that you are tracking this as a distinct actor than the other vendors in the industry?
Is there a particular reason that we are tracking this campaign, or that we are attributing it to the APT?
Why are you attributing this campaign to APT38
so
instead
first,
of famous Cholima as everyone else?
Yeah, so, well, different companies name threat actors differently. Yeah, in this case, well, we are talking about North Korean actors, well, and specifically Lazarus. We've attributed this because the tools that they have used, the endpoints that they have used in this case, but also they were used for other, well, North Korean operations, I would say. And
well, true, but Stardust Cholima is their main focus is on financial side, on crypto side.
Well, but
rather than famous Chalima, whose interest is to financial gains to sponsor their activities for their own and the regime.
well, you might be right, but there is always like an intersection between these groups, and it really depends on who tells the story, I would say. So, well, different companies would basically attribute it to different subgroups, and some would see them as larger blocks of operations, some would just see them as really specific teams that undergo specific campaigns, I would say. Well, of course, one common thing between all of this is the crypto focus, as we see also today. So they mostly focus on compromising or just exfiltrating data about crypto-related extensions, running crypto miners, and extracting wallet phases, seeds, and all that.
Right, but in the containers interview, there was not 100%, the tsunami loader was not 100% deployed. So you only have like...
Could you say it a bit louder?
So yeah, during the contagious interview interactions, the tsunami loader was not 100% of the time deployed. They only deploy like beaver tail or invisible ferret, which make us think that the first part is done by a team and the second part would be handled by Stardust Chalima.
Yeah.
That's why I was asking.
Yeah, I'm not saying that you're not right, but just the fact that everybody has the, well, kind of freedom to attribute it to different subgroups and, well, teams, specific teams in the, well, regime that you've mentioned. So thank you for the question.
Thank you.
All right, thank you. Is there anything else that you would like to ask? Going once, going twice? Give it up for Ionuț. Thank you so much.
Thank you.